Hello dear students, we come to the lens formula. This is a very important formula and I will be teaching you the derivations of the lens formula from your textbook. Okay, first but we'll just look at this formula. Lens formula is equal to 1 by v minus 1 by u, that is equal to 1 by f. So 1 by v minus 1 by u is equal to 1 by f means that 1 by v, what is v? Image distance, and u is object distance. So when you connect object distance and image distance by this formula, you will get the value for focal length f. Okay, so this is an equation, but when you are using this equation for numerical problems, you must always see that you use the correct sign convention, okay, and give the correct sign for v, u and f, whatever you know. So your final answer will also be correct according to you will get the answer correct according to the sign convention. Okay, so we will try some numerical problems. I will try it with you on the online mode, okay, later on. Then linear magnification. Okay, we know what is the meaning of magnification. Magnification means how many times the image has been enlarged as compared to the object. So if we know the length of the object and if we know the length of the image, so when we divide it, length of the image by length of the object, we get a factor which is known as linear magnification. Okay, like if suppose the size of the length of the object is 2 centimeter, but length of the image is 10 centimeter. So how many times the object has been magnified in the image? So we will write 10 by 2, that is 5 times. So everything has increased 5 times. So that is the meaning of magnification. So here we will just read this. It is not sufficient to know the position of the image of an object by a lens, but it is also required to know its size. So when you are solving the problems, you can not only know the positions of object or image, but you can also know the size. When the position of an object changes, there is a change in the position as well as the size of the image. You all have seen the different cases and you know that as you change the position of the object, the position of the image changes as well as the size also changes. Either it is enlarged or it is diminished, isn't it? So when we take a value, the ratio of length of image I perpendicular to the principal axis to the length of the object O is called the linear magnification. So it is generally denoted by the letter M. So linear magnification is M. So how can you find the linear magnification? It is the length of the image or size of the image by size of the object. So that is the value for magnification, and also it can be connected to the distances. Okay, magnification is V by U, that is object image distance by object distance. So we can use both the formula, whatever the case may be, whichever is given, to find the magnification we can use either I by O or V by U. So that is very simple. Now remember, for linear magnification for the real image, so real image is inverted, isn't it? So when you take the object length of the object, you will get a positive sign because it is above the principal axis. But when it is a real image, it will be inverted, isn't it? So the value for I will be negative. So always for real image, the magnification is negative. While for virtual images, in virtual images you know that we get an erect image, an upright image. So both the object and image will be above the principal axis. So we have to take a positive sign. So virtual image has a positive magnification while real images have a negative magnification. Thus a convex lens can have the value of M, positive as well as negative. Can you tell me the answer? When the value of convex lens, when the value of M for convex lens becomes negative, please text me the answer, okay, after you listen to the video. But concave lens always has value of M positive. If the value of M is greater than 1, that means the image is magnified. If it is equal to 1, that means it is of the same size. So you answer this question also. In which case of convex lens the magnification will be 1. Okay, and if it is less than 1, that means the image is diminished. So concave lens will always have which type of magnification? It will always have a value less than 1 because always the image is diminished in case of a concave lens. Okay. Now I hope you have understood linear magnification. Now we will be solving numerical problems after this.